So far with improper integrals, we've had negative infinity as the lower bound and positive infinity as the upper bound, and we've had both in the problem. Well, this time we're not going to have infinity in the problem, but we will end up having something going on with the problem. One example might be if I'm going from -1 to 1 and I have the integral of 1 over x. My problem would be I could definitely type in -1 and I can plug in 1, but in the middle of there is 0, and this function is undefined at 0, so that's what we're going to be dealing with in the next 3 videos. If I have a place where there is a discontinuity and I'm trying to take the integrals, can I still get the integral? At the end of this specific lesson, you'll be able to evaluate an integral with an infinite discontinuity at its upper bound. All right, so basically what is going to be happening, I'm going to set up the problem first and then we'll read through this definition. So if I would like to, oh goodness, if I would like to evaluate the integral from 0 to 2 of 1 over x, basically that's asking me again to find the area under the curve from 0 to 2. So I've got 1 over x, which looks like this, and I would like to find the area under the curve from 0 to 2. Please notice that we actually can't find it starting at 0 because there is a discontinuity at 0. So what I'm trying to figure out is can I find an answer for that area? That's what we're going to be doing. The way that we're going to be handling that is we actually are going to be approaching 2, because as I'm coming in, it's going to go from 0 to 2. I'm going to be approaching that discontinuity from the right side, from the positive side. So what we are going to do is we are going to be replacing the 0, replacing the part that has the discontinuity with the letter again, and I will again be using the letter W, and we're going to be finding the limit as W approaches that discontinuity from the right side. So we're going to be heading in towards the discontinuity from the right side. So we are going to turn this into the limit as W approaches my discontinuity, which is 0, from the right side of the integral of W to 2 of 1 over x dx. All right, and so just like we did in the other problems, we're going to evaluate the integral, then we're going to find the limit of that answer. This time, though, it will be as W approaches 0 from the right side. So let's tackle this integral. The integral of 1 over x we learned is the natural log of x, so it's the natural log of x. We're going to evaluate it at 2 and at W. So this will be the natural log of 2 minus the natural log of, not the ln, the ln of W. This is as far as I can evaluate that integral, so I'm ready to find that integral as the limit as W approaches 0 from the right side. Okay, so now what's going to happen, you'll notice if I try to plug in 0 to this, the natural log of 0 is undefined. So we're going to have to think of what the natural log looks like to see what is happening as we approach 0 from the right side. So when I do this, the natural log picture, this is what the natural log function looks like. Okay, and we would like to approach the natural log, we would like to approach 0 from the right side. So as I'm coming into x equals 0 from the right side, please notice that I'm heading down towards negative infinity. So this limit right here will have a limit of negative infinity. So I have ln 2 minus negative infinity, which will be turned to plus infinity. So you'll notice I get the natural log of 2 plus infinity, which is definitely infinity. So this area diverges. So we actually do not get an answer for that area. So hopefully now you can find the integral if we have a discontinuity on the lower bound.